Okay, now we're going to be talking about the unit circle. Why the unit circle? Well, the unit circle is useful because there are some patterns with these specific given angles. 0 degree, 30, 45, 60. And by the way, these are kind of the main angles that we'll be dealing with, but we also on the unit circle exist 90 degrees, 180 degrees, 360 degrees. And a couple things to keep in mind: which quadrant, remembering labeling the quadrants, or to keep that in mind. And then what are the x and y values? So if you have a point right here, let's call that 3, 3. I'm probably off on that, but I can call it whatever I want. 3, 3. Look at both of those, both the x and the y value are positive. If we were to plot a point right here, x value, we went to the left, but we still went up, so we went to the left, which is negative, but we went up, which is positive. If we plot a point right here, well, we went to the left, which is negative, and we went down, which is also negative. So the x is negative and the y is negative. If we plot a point right there, well, on the x-axis, we went in the positive direction. But we also had to go down to get to that point, and down is the y value. Okay, so let me, although this was kind of silly, move this out of the way. So we're going to have this unit circle, and there's going to be some patterns within the unit circle dealing with the 30, or pi 6, the 45 degree, or pi 4ths, or the 60 degree. 60 is from there to there, 45 is from there to there, 30 is from there to there. Okay, so first we're going to talk about the 30 degree, which happens to be pi 6. Well, what you need to know that there's patterns. If we go 30 degrees from this side of the x-axis in the first quadrant, we're at pi 6. And that coordinate point right there, we just go the radius of 1. By the way, the unit circle, I should have led with that. The unit circle is called the unit circle because the radius is 1 unit on the unit circle. That's why it's called the unit circle. And that's where all these special relationships come from. Well, at that point right there, the x value is root 3 over 2. So from here to here is the distance of positive root 3 over 2. And then we go up to 0.1/2. So that's its coordinate point. Well, if we reflect over the y-axis, this distance, if we were to do that, is negative root 3 over 2, but we still went up 1/2. And if we put a point right there, we went over negative root 3 over 2, and we go down negative 1/2. And if we put a point right here, we go over positive root 3 over 2, and we go down. So look at all these coordinate points. Those values almost all look the same. It's just that their signs are different. So as long as you're paying attention to the signs and you understand the pattern of all 30-degree angles, all 30-degree reference angles. So here's a 30, oops. I'll do this in red. Here's a 30-degree reference angle. Here's a 30-degree reference angle. Here's a 30-degree reference angle. 30 degrees away all have these coordinate points. You just have to pay attention to the signs. Okay, the other thing that you need to keep in mind is they're all going to have the denominator of 6. So let's count by 30. So there's 130. Go 30 more. We end up here. Go 30 more. So that's 1, 2, 3, 4, 5. So this is 5 pi 6. Well, at pi, that's the same as 6 pi 6. So this right here would be 7 pi 6. And if we went all the way around the circle, 2 pi is the same as 12 pi 6. So 1 less than 12 is 11 pi 6. So 1 more than 0, because remember that this is both 0 and 2 pi. 1 more than 0 is 1, so 1 pi 6. 1 less than 6 pi 6 is 5 pi 6. 1 more than 6 pi 6 is 7 pi 6. And since 2 pi and 12 pi 6 are the same, 1 less than 12 is 11. Okay, so those are the pi 6s. Now the pi 4ths, or 45 degrees, you're going to notice the same pattern. So here's 1 pi 4th, so 45 degrees more is right there. So that's 2 pi 4ths. Well, 2 pi 4ths is the same as pi half, so that should make sense. Those two mean the same thing. So that's 2. Well, this is 3 pi 4ths. And 3 pi 4ths has the same coordinate points except for the x value is negative. Then pi is the same as 4 pi 4ths. And if you go one more 45 degrees, you're at 5 pi 4ths. So look at what we have. Since this is the same as pi, pi is the same as 4 over 4. 1 less is 3. 1 more is 5. If we go all the way around the circle, this is 0 and 2 pi. Well, 2 pi, if 4 is in the denominator, 8 divided by 4 is 2. So 1 less than 8 is 7 pi 4ths. And if we are talking about degrees, I should have done that with 30. If this is 180 degrees, subtract 45, and you get 135 degrees. Add 45, and you get 225 degrees. And since 2 pi is the same as 360, 360 subtract 45 is 315 degrees. And I should have done that over here with 30. So if this is 180 degrees, 30 less, we're at 150 degrees. 30 more, this would be 210 degrees. And since this is the same as 360, 30 degrees less, this would be 330. All right, so the last one is pi 6s. Pi 3rds, excuse me. And that's 60 degrees. We're going to carry that across. So all of these reference angles that we see right here will have a denominator of 3, and they'll all be 60 degrees away from that x-axis. So if this is 180, 180 subtract 60 is 120 degrees. 180 plus 60 is 240 degrees. And since this is 360 degrees, it's also 0 degrees. It's also 2 pi. And 2 pi, if 3 is in the denominator, would be 6 pi 3rds. I'll use that in a second. So 360 subtract 60 is 300 degrees. Now we're talking about pi 3rds. 1 more than 0 is 1 pi 3rds. Since this is 6 pi 3rds, this would be the same, pi would be the same thing as 3 over 3. 1 less is 2 pi 3rds. 1 more is 4 pi 3rds. And then if all the way around is 6 pi 3rds, 1 less is 5 pi thirds. And then again, notice these coordinate points, x is 1/2, y is √3/2. They're all the same for the 60-degree angle. You just have to pay attention to the sign attached. And then you're also going to need to think about what the axis points are. So at this point right here, that is 1, 0. So the x, we went out 1, but we went up a height of 0. We didn't go up a height. So on this side, that would be negative. Whoops, -1 and 0. And then when we look at the y-axis, well, the y-axis, we didn't go anywhere for the x. We stayed right on the x-axis. So that's 0. And right here, that's +1. And down here, we went down to -1. All right, that's it for the unit circle. But the unit circle is what you're so dependent on. There's a lot of times that you cannot use a calculator. You need the unit circle. All right, that's it for the unit circle.